Hey guys, this is Mr. Anziano one last time to finish up the end of the Unit 6 test review for part 5 of our video series here. At the end of part 4, you're just getting to this answer that t was equal to 3.961, right? And what that means in the context of this problem is that the first signs of growth would appear at the end of the third day. The first signs of growth, right when we're going to get an output of 0, the first signs of growth, or at least we go from negative to positive, right? It's going to happen not at 3.5 days, not at 7 days, somewhere between those two, right? Definitely a lot closer to 3.5 though. The first signs of growth are going to occur at the end of the third day. Okay. End of the third day. I'm writing quickly, so forgive the chicken scratch there. All right. Once a plant has reached a height of 120 millimeters, it can be sold. On what day after planting will the plant be able to be sold? Well, similarly to what we just did up in for letter B, we would want to know when the height is going to be equal to 120. So we actually let the height be equal to 120 and solve. So 120 equals 2 plus 50 times the natural log of t minus 3. Or in other words, 118 is equal to 50 natural log t minus 3 if I subtract 2 from both sides, right? And dividing both sides by 50, we get 118 over 50. I'm just going to figure out what that is because it looks like maybe it'll be a nice decimal. 118 divided by 50 is 2.36. Okay. That glare is pretty awful, but that says 2.36. Let's turn the brightness down. That might help. Yep, there we go. All right, 2.36. So we have 2.36 on the left is equal to natural log of t minus 3 on the right. So how do we undo a natural log of t minus 3? We have to raise both. We have to take e and raise it up to the power of both sides. So e to the 2.36 power is going to be equal to e to the natural log of t minus 3. But e to the natural log of t minus 3 is just t minus 3. So we get t minus 3 equals e to the 2.36 power, or in other words, t is equal to e to the 2.36 plus 3. And what is that, you ask? I don't know. Let's see what the calculator says. E to the power of 2.36 plus 3 is equal to 13.591. Right? So what does this mean? Well, it means that the plant will reach a height of 120 millimeters at exactly 13.591 days. So it can be sold basically in like the second half of day 13, right? So maybe afternoon, the afternoon of day 13. In the afternoon of day 13. That's when it'll be 120 millimeters. All right, and there you go. That's number 23. All right, now looking at the backside, we have a full 11 minutes to record the backside of this test review. So let's make it happen. All right. Here for number 24, the very final problem, we have two functions to consider. Consider the logarithm functions below to answer the following questions. F is negative 2 plus natural log of 6 minus 2x, and g is 2 natural log x plus the natural log of x plus 2. For what values of x is f of x equal to 5? Leave your answer in terms of e because that is the best answer, right? Are there 0, 1, or 2 solutions? F of x. So we got to figure out when f of x is going to be 5. So we take f of x, literally replace it with 5. Set that equal to negative 2 plus the natural log of 6 minus 2x. And let's figure out what we get for x. Okay, so if I add 2 to both sides, I'll get 7 is equal to the natural log of 6 minus 2x. And again, we're going to take e and raise it up to the power of 7, and then we're going to take e and raise it up to the power of natural log of 6 minus 2x. That goes away, and we're left with e to the 7th equals 6 minus 2x. So, if I subtract 6 from both sides, I'll get negative 2x is equal to e to the 7th minus 6, and then if I divide both sides by negative 2, I get that x is equal to negative e to the 7th minus 6 all over 2. All right. That's my answer there. And that is how many solutions? It should be just one. All right, one solution. Next it says identify the equation of the vertical asymptote of the graph of f of x. Does the graph lie to the left or to the right of the vertical asymptote? Show your work and explain your reasoning. All right. Well, for this next situation, we need to take the argument, right? We need to take the argument of the function in f, this 6 minus 2x expression, and set that equal to 0. So if 6 minus 2x equals 0, then that means negative 2x is equal to negative 6, which means that x is equal to positive 3 is going to be the equation of the vertical asymptote. So x equals 3 is the vertical asymptote. Does the graph lie to the left or to the right of the vertical asymptote? Well, because the argument has a negative sitting right there in front of the variable, we know that the values are going to lie to the left of our vertical asymptote. And that's essentially all the reasoning we need. Because the argument has a negative in front of the variable, the graph lies to the left of the vertical asymptote, which was x equals 3. Oh, lost some words there, but there it is. Left of the vertical asymptote. Okay, next, letter C. Find the equation of f inverse of x, and we want that to be an exponential equation. Okay, so we need to first write it out as y equals instead of f of x equals, and I'm looking back up here, I'm just going to rewrite this f of x function, but in terms of y equals, so negative 2 plus natural log of 6 minus 2x. Okay, and then we're going to switch x and y, so we get x is equal to negative 2 plus the natural log of 6 minus 2y. Add 2 to both sides, and I get x plus 2 equals the natural log of 6 minus 2y. If I take e to the power of both sides, then I'll have e to the x plus 2 is equal to e to the natural log of 6 minus 2y. So then e to the x plus 2 is equal to 6 minus 2y. E to the x plus 2 minus 6 equals negative 2y. Divide both sides by negative 2, and we get y is equal to e to the x plus 2 minus 6 all over negative 2, right? But if we get e to the x plus 2 minus 6 all over negative 2, then technically we can rewrite that as y equals negative 1/2 e to the x plus 2, and then negative 6 divided by negative 2 is going to actually turn into plus 3. So I'm splitting this first term and the second term apart in the numerator and dividing them both by negative 2, right? So we get negative 1/2 e to the x plus 2 plus 3 as our equation, right? So I'm actually looking over here to my left for a quick second. Negative 1/2 e to the x plus 2 plus 3. Yep, that is the equation. Okay, so that's our inverse. And next, we need to finally figure out for what values of x does the graph g of x equal the natural log of 3 of x? Natural log of 3x. And show your work. Are there 0, 1, or 2 solutions? All right, so for this, we need to figure out when g equals the natural log of 3x, right? Well, we have g up here. We haven't really used it yet, but there it is. G of x is equal to 2 times the natural log of x plus the natural log of x plus 2. So I'm actually going to rewrite that here so we can kind of just look at it in one space. 2 natural log x plus natural log of x plus 2. There it is. All right. I'm actually going to condense that into one logarithm first because I think that's going to make it a little easier. So that's equal to the natural log of x squared plus the natural log of x plus 2, which can be combined into the natural log of x squared times x plus 2, which really just turns into the natural log of x cubed plus 2x squared. Right? And the question is, when is the natural log of 3x going to be equal to the natural log of x cubed plus 2x squared? So I'm actually just going to put the natural log of 3x right there on the left. Okay, I'm kind of breaking this up now. We're looking at the next part. So when is the natural log of 3x equal to the natural log of x cubed plus 2x squared? Well, in order to figure that out, I can actually just, because there's a natural log on both sides of this equation now, I can just take 3x and set it equal to x cubed plus 2x squared. And now I'm going to bring it up here for some more space. Of course, to solve that, I want to get 0 on one side of the equation, so I'll have x cubed plus 2x squared minus 3x is equal to 0, which allows me to factor an x out, and I'd have x times x squared plus 2x minus 3 is equal to 0, which means I need to factor. So we're going to have x times one expression times another expression is equal to 0. Well, what are the values that multiply together to equal -3 and add up to +2? If you say +3 and -1, you would be correct. X times x plus 3 times x minus 1 is equal to 0. So what are my three solutions? Turns out, well, we're going to get x is equal to 0, -3, and +1. Okay, well, now we need to check those answers, right? Does 0, -3, and 1, do they all work? And how do we check that? Well, that means that we need to go back to where we started. Does the natural log of 3x equal the natural log of x cubed plus 2x squared? Well, let's try 0. Does the natural log of 0 equal the natural log of 0 plus 0? Well, I don't know. What is the natural log of 0? Can we even do that? Does 0 work? Maybe you can plug it in, but if you look for the natural log of 0, you're actually going to get a value that's undefined. So 0 cannot be an answer. Okay. Try -3. Does the natural log of 3 times -3 equal the natural log of -3 cubed plus 2 times -3 squared? Well, again, the natural log of 3x when x is -3 gets you the natural log of -9. And there is no natural log of -9 because -9 is negative. So -3 doesn't work either. Let's see if 1 works. Does the natural log of 3 equal the natural log of 1 cubed plus 2 times 1 squared? Well, the natural log of 3 times 1 is, again, just 3, so we have 3 inside the argument, right? We'd have 3 there, and then 1 cubed is 1, plus 2 times 1 squared is just 1 plus 2, so really, x cubed plus 2x squared, when you plug 1 in, turns into 3 as well. So you end up getting 3 inside the argument here and 3 inside the argument here. And yes, the natural log of 3 does equal the natural log of 3, because they're the same thing. So 1 is good. So the only solution is x equals 1. And to answer the question, are there 0, 1, or 2 solutions, then we know that we have only one solution. All right, and that's it for the Unit 6 test review, guys. That is the end. I hope you got a lot out of this informational session from Mrs. Keener and myself, and that you feel ready to take the Unit 6 test coming up on Friday. All right, guys. Happy studying.